Hey there, mathematicians. So this lesson is going to deal with domain and range of graphs. So remember, the domain is just all the possible input or x values in relation, and the range is all the possible output or y values. So we're going to be looking at the x and y axis. And remember, the function is just a relation where every element of the domain relates to only one element in the range. So the graph cannot stack itself vertically. So when we look at domain and range, we're going to write it down in two different ways, as an inequality and also as interval notation. So if we're looking at domain, it's the x number, so we're going to put x in the inequality, and we're just going to highlight the x-axis everywhere we see the graph. And since there are arrows that are still going to the side, I'm going to put arrows here, which means this domain goes all the way back to negative infinity and all the way up to positive infinity. So the domain is negative infinity is less than x is less than positive infinity. Now, mathematicians are lazy, so we're not going to write it like this. We're going to write it so it looks kind of like a coordinate. So there's parentheses, negative infinity, comma, positive infinity, and another parentheses. Now, these parentheses mean that the negative infinity is not included in the domain. That's because negative infinity is not a number, it's an idea. When we look at the range, instead of x, it's going to be y. It's going to have the same inequality signs. Remember, it's not or equal to, because infinity is not a number. So we're just going to highlight the y-axis every place that the graph exists, and I'm going to put arrows at the end because these arrows go up and down, which means it goes down to negative infinity and up to positive infinity. It's a parenthesis, negative infinity, comma, positive infinity, close the parenthesis. Okay, this example is a little different. With the x, we see it from here to here, and it's got arrows, so it's going to look just like this one. So negative infinity, less than x, less than infinity. But the y value, the range, starts here. There's no arrow going down because it literally starts there. We're going to go up with an arrow. So that means it starts at 2. That's the lowest the range goes. And it's less than or equal to because it includes the number 2. Remember, that's a y. And up to positive infinity. So when we write this in interval notation, it's a bracket because that tells you that it includes the number 2. It's a comma, goes up to infinity. And this is a parenthesis because it does not include infinity. So here we have a couple of other examples. Again, there's no equation for this. It is a function because every x only maps to one y. This is called a piecewise function. It goes in pieces. So if we look at the x-axis, it starts here, goes all the way over, and it ends here. So the lowest number is negative 9, the highest number is positive 7, and it includes the negative 9, so it's less than or equal to. It includes the 7, so again, it's less than or equal to. So when we draw this in interval notation, it's a bracket, not a parenthesis. So negative 9 comma 7 says the domain goes from negative 9 to 7 and includes both of those. So with the range, the lowest it goes is negative 6. Follow the y-axis up. So that's where it ends over here, but it actually goes all the way up to 4. So we're going to say it goes from negative 6, that's the lowest it goes, up to positive 4. It's y, because it's the range, and it includes those numbers, so it's less than or equal to. So we're going to say, again, it's a bracket, negative 6, comma, 4, another bracket. This example here, we have it domain. The furthest left it goes, the lowest number we see is 2. And we follow it all the way over here, and we see it's got an arrow. So the lowest it goes is 2. The highest it's going to go is positive infinity. It's x because it's domain. It includes the 2, so it's less than or equal to. But again, it's only less than because infinity is not a number. So this is going to be a bracket to include the 2, and infinity, and then a parenthesis. So the range in this case, the lowest it goes is down here, and it's an arrow because it goes down. The arrow says it goes down. We follow it up, and the highest it goes is positive 5. So the lowest we're going to go is negative infinity because the arrow says it goes down forever. The highest it goes is 5. It's y because it's the range. That's just a less than because it doesn't include infinity. And this is less than or equal to because it does include the number 5. So parenthesis for the negative infinity, comma, and a bracket for the 5. This is a funky looking graph. We can still find the domain, the range, and decide if it's a function or not. So domain on the x-axis goes low as you see the graph. That's here at negative 5. Highlight the x-axis where you can still see the graph, and it stops here at 10. Now with the domain, again, we're going to write it both ways. It goes from negative 5. It includes negative 5, so make sure there's a line under your inequality sign, but it does not include the 10. So when you write your inequality sign, make sure there's no line under it. So that means this is a bracket, that's a parenthesis, and it goes from negative 5 to 10. So the range, again, the lowest we see is down here at negative 3. Then we go up, 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 up. It stops here, but the graph still keeps going up to here, positive 3. So we want all of this. Now it includes the negative 3, but since that's an open circle, it doesn't include the positive 3. So negative 3 to positive 3, we're talking about y because of the range. It includes the negative 3, so make sure you put a line under it. It does not include the positive 3. So that's a bracket, that's a parenthesis for the negative 3 and positive 3. Is this a function? If you run a line, a vertical line, across this, this is a function. The vertical line will only hit the graph at one point at any time. The graph does not double back on itself. It doesn't do this kind of thing. There are no 2 points stacked above each other. So yes, this is a function. The only reason relation is a function is because every input has exactly one output, or only one output. And that's domain range of graphs.